This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to discuss about a sorting technique known as Quicksort. Sorting is nothing but arranging the data in either ascending or descending order. There are various types of sorting techniques like bubble sort, insertion sort, selection, quick, merge, and heap. So out of all these sorting techniques, quick and merge have a special property because they perform based upon divide and conquer. The beauty of this. Okay. Let's discuss about quick sort today. It is a sorting technique which is based upon divide and conquer. Here we are going to pick a pivot element, an element within the list, and we are going to search for the right position of that particular element in a sorted list, right? In that particular sorted list. So that pivot element can be the leftmost element, rightmost element, or the middle element, or any random element. It can be any element. So the logic of the quicksort is the same. So as soon as we place the first element at its right position, all the elements left to it becomes the left half. All the elements right to it becomes the right half. And recursively, we are going to perform the same logic on left part as well as the right part. That means at each and every iteration, by the end of each and every iteration, we are going to get two new sublists in our hands, which undergo the same process, the same logic, right? We'll have a look of quicksort with an exam as well as an algorithm. So coming to the complexities of quicksort, so the best and average case is complexity time. Complexity is order of n log n, whereas the worst case is n square. So the memory which it is going to use is the same, the size of the list. It needs some temporary variables like to store the pivot variable, left element variable, right element variable, some simple temporary memory, nothing much, right? And it is not a stable algorithm because it is not going to divide the list into two halves. It is going to randomly, depends upon which pivot element you have selected and where it actually lies in a sorted list. So by the time of division, it will be divided not into two equal halves, but two different halves, right? So it is not a stable algorithm. Let's have a look at the algorithm. So choose the highest index or the lowest index. It all depends upon you, how you want to do. Okay, take two variables, left and right, and assign them to the left and right index values. The first iteration I'm talking about. Now start the comparison. While the value of the left is less than the pivot, move towards right. Once that breaks, go to step 6. While the value of right is greater than pivot, move towards left. If both the steps fails and the left is going to cross the right, then swap the content of pivot and right. I'll explain you with this an example. Have a look at this one. So the given list is 5, 3, 8, 1, 4, 6, 2, 7, where I have taken the leftmost element as the pivot element, right? So now my indexing starts. So for example, index value 0, 1, 2, 3, 4, 5, 6, and 7. As pivot element is going to hold the element at 0th index, my left is going to hold 1 greater than that, which is the index value 1, and right is going to hold the last index, right? I hope you understood my assignments. So how up you guys, you can start with the highest element as the pivot element. That is the element pointed right now by the right can be the pivot element. And in that case, if this is the pivot element, then the leftmost element will be the left element and 1 less than this will be the right element. Even you can work in this fashion also. The logic is not going to change. Okay, let's stick to this point now and have a look at this example. Okay, so let's start our comparisons. Compare the pivot element 5 with the element pointed by left, L, that is L. So as L element is less than pivot, shift it. So now L is pointing to 8. Is 8 less than 5? No, the condition fails. So left will get freezed and it will be pointing to 8. Now the process start with right. The element pointed by right is 7. Is it less than pivot element or not? It is greater. So shift the same. Right is been shifted to 2. Right is been shifted to 2. Is 2 less than 5? The condition satisfied. Right? Now have a look at this picture now, the last one. So the element pointed by left is greater than pivot and the element pointed by right is less than pivot. Now swap the contents of left and right. Right? Swap the contents of left and right and start the process again. That means move the left element towards the right direction and stop wherever you find an element greater than the pivot. Let's do the same. Okay, so now left is point after swapping the left and right. So left is pointing to the element 1 and right is pointing to the element 8. Right? Is 1 greater than 5? No. So shift left. Now left is pointing to 4. Is 4 greater than 5? No. Again, shift left. Now left is pointing to 6. Yes, 6 is greater than 5. Freeze it. Now start working with right. Now right is going to point to my element 6. Right? Is 6 less than 5? Right always checks for an element which is lesser than the pivot. But 6 is not less than pivot. So it is going to shift left. Now right is pointing to 4. Is 4 less than 5? Condition satisfied. And have a look of this picture. Left, the index value of left is more than right. That means right have crossed left. Now this is the right time when our while loops are going to break and swap the elements pointed by pivot and right. When you swap it, you are going to get this list. So now have a look. The pivot element 5 is in its right position. Okay, the pivot element is in its right position. As Quicksort works on divide and conquer, now you can see that the whole list is divided into pieces. 2 pieces. Not exactly equal, but they are divided into 2 pieces such that all the elements left to 5 are one subarray and right to 5 are another subarray. Within the left subarray, pivot element will be the leftmost and 1 greater than pivot is left and right will be the rightmost element in the sublist. Okay, I'm talking about this sublist which is left of 5. In the same manner, coming to the right of 5, this is another sublist where 6 acts as pivot, 8 acts as left, and 7 acts as right. The same logic which we have seen means check for an element which is greater than pivot from left hand side and move the left header towards the right. Freeze over there and start working with the right pointer. Search for an element which is less than the pivot and move towards left. When you encounter that, swap the elements in left and right. If right crosses left, then swap the elements of pivot and right, and thereby you are going to again divide the list into 2 halves. This process is going to go recursively unless the whole list is being sorted or you attain a place where your pivot left and right are pointing to a same element, a single element. Which means that we cannot further divide the list, right? So the final list will be a sorted list 1, 2, 3, 4, 5, 6, 7, and 8. So the final list will be a sorted list of 1 to 8. So I hope you understood Quicksort. Let's go for a quick review of Quicksort. Quicksort is an algorithm which depends on divide and conquer, where at the end of each and every iteration, we are going to break the list into two halves. And in two halves, the left half will be working on the same logic, and the right half is also going to work on the same logic. And the quicksort algorithm will be written using recursive functions. I hope you understood this one. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.